we have, right? If we use this data, we cannot estimate, right? We need to transfer the qualitative information to quantitative information. That means the categorical data to the continuous data, right? And so how to train? So we define here, we define the qualitative information, right? May train or may turn into the qualitative information, right? By using the binary coding for yes or no. Yeah, yes or no. So for example, in your sample, you ask observation, right? Is the person is in the sample is female, right? If they answer yes, right, you got one. Yeah, you got one. And if they answer no, you got zero. Yeah, you got zero. And the variables here only have two values, right? One or zero. Yeah, one or zero. One if they're female, and zero if they are male, right? And another sample, for example, employed or unemployed, or the financial rises and non-financial rises. Yeah, and the variable, the way you code here, right? You code S variable equal to one if a person is female, and equal to zero if it is not female, that's mean male, right? We call it a dummy variable. Yeah, dummy variable. Dummy variable here or indicator variable or binary variable or 0 1 variable. 0 1 because they only have two values, right? 0 or 1. Yeah, 0 or 1. So we have dummy variable, indicator variable, and binary variable or 0 1 variable. It is same. Yeah, and you can include in the dummy variable as a S variable. That's mean independent variable or Y variable. It's okay. Yeah, Y, S or Y. Yeah, and for example here, the gender we have the first observation it is female, right? For example, you survey this wage and the salary here or the education here, and the first up the first person answer you it is female, right? And so you define female here, right? Female here, you define, okay, you we define female here is a dummy variable, right? Dummy variable that here equal to one if person here is female and equal to zero otherwise. Otherwise, that means a person is male. Yeah. So this is the way we define the dummy variable, right? Female is a dummy variable equal to one if a person is male and zero otherwise. That means male. For example, here you can see the first observation or the first person answer you is female, so you got one. Yeah, you got one. And similar female, you got one too, right? And the third person it is male, right? So you got zero. Here, male, you got zero too, right? You got zero too. And you can see the female here only have two values, one or zero. Yeah, one or zero. So this is the dummy variable, right? And now if we including this model in our, and similar here we have marriage, right? If a person is married, right, we have zero. If a person is married, so sorry, if a person marriage is married, right, we got one. Unmarried, we got zero. Yeah. And now how we is interact the coefficient here. Yeah. So we define we have dummy variables, right? Is a variable that equal to 0 or 1. Yeah, 0 or 1. And the coefficient of dummy variables is equal to the intercept to the when dummy equal to 1. Yeah, so you remember when we interact the coefficient, we say what? We say the when independent variable s, right, in real one unit, right, in real one unit, right? That's that here the dummy variable, right, only have two values, 0 or 1. That means the coefficient on dummy variable here, right? That's so the effect of when dummy variable equal to 1. Yeah, one when dummy variable equal to 1, and on all the coefficient unchanged. Yeah. So because here we have the coefficient here, that means it may be positive, maybe negative, right? That means the weights here gain or loss if the person is woman rather than a man. Yeah, on other variable constant. Yeah, on other variable constant. Okay. For example, how we mm, Okay, let's see a sample. Okay, here we have marriage and unmarried, right? And we define similar here, the marriage equal to 1, right? If a person is married, right? And equal to 0 if it unmarried, right? And now we estimate the model. For example, we have the education. Okay. Right. Regression here. Okay. De dependent variable still wait, right? But now we have the independent variable. Independent variable. So I choose the education and marriage, right? Education. Okay, this is the result I have, right? So now I have two independent variable, right? Marriage and education. Yeah, marriage and education. Yeah. And now how to explain the coefficient here? Okay, I will copy the result to work. No, to work. Okay, here, right? So if we transfer this model to the equation forms, so what we have here is the wage, right? Wage, embedded value wage equal to the constant, right? The constant here, right? And then we lost, right? We lost the coefficient on the education, right? And we have HU. And we have the coefficient on marriage, 1.5247. This is the marriage, right? And marriage is, I not right here, the equal marriage here equal to 1 for the marriage, yeah, person, and equal to 1 for the marriage person and 0 otherwise. That means unmarried, right? Okay, this is the definition of the marriage, right? Marriage person and 0 otherwise. And this is the model we have, right? This model we have. Yeah, that's model we have. And we also saw the standard errors here, right? Yeah, and then we have the standard error for education. Yeah, and the standard errors for the so it's the so it is marriage. And this is for the education. Yeah, education, right? In addition, we also ask where, right? And the number of observation here n equal to 126 and ask where here equal to okay 20.6%. Yeah. Yeah, okay, 20.6%. This way we saw the uh equation, right? Okay, estimated result using equation. Yeah. And now how to explain the coefficient on the marriage, right? How to explain a coefficient on marriage. So to explain the coefficient education, we know, right? Okay, how to explain the coefficient on the HU? Okay, how to explain? Anyone tell me how to explain the coefficient on education? So here we have the coefficient on the equation here equal to 0.5262. So how to explain the coefficient here? how to integrate the coefficient and the marriage, right? We know that one, the marriage increase 1 unit, but you know that the marriage only has two values, right? 0 or 1. Yeah, 0 or 1. So if we say the marriage in we 1 units, actually it has no meaning. Yeah, has no meaning. So for the marriage, we have the expected value of wage for the people have the education level equal to 10. Yeah, equal to 10. Yeah, and they are unmarried, right? Otherwise, that means unmarried people, right? And here I would like to calculate for the unmarried, right? So I have 0 here, right? The coefficient on the marriage is 0. Okay, this is the wage, right? Wage for the uh, unmarried people with the education level equal to 10. And now I will calculate the wage for the people, right? Marriage people. Yeah. And the same education level, right? The same education level, right? And here we have, sorry. Okay, here we still have constant, right? We have the coefficient on the education, right? And then the education level equal to 10 too, right? And now this is marriage people, right? And marriage people here have the, because they are marriage people, right? This that's mean uh the variable marriage equal to 1. And here we have the coefficient of marriage time 1. Yeah. So you can see here, this is the expected value wage for the unmarried people with the education level 10. And here it is the marriage, right? The wage for the married people, right? Married people with the same education level. So what is the difference between two of them? It is 1 here minus here. So we have here, this is the coefficient on marriage, right? You can see here, it is coefficient on the marriage. Yeah. You have this coefficient on the marriage. So the coefficient here, this will lead to the coefficient here. This shows the difference in wage between the married people and unmarried people, right? Unmarried people. Okay, here, our main group here is the marriage. So for the dummy variable, the value you define is 1. We define it the main group, right? The marriage person here. We define it the main group, right? And otherwise, or the 0 here, we define it as base group. yeah, base group. So or the reference group, right, base group. So the coefficient on dummy variable here, right, indicate the difference in the dependent variable between the main group and the base group, right? And so in this situation, how to explain the coefficient here? We say, so the marriage person here, right, earns more than unmarried, right, person here by 1 point, by the coefficient 1.5247. Yeah, so this is the way we iterate the coefficient on the dummy variable. Yeah, on the dummy variable. But here, this is for the multiple regression model, right? We say holding here on other variable constant, right? The married person here, married people here, earns more than unmarried person by the coefficient. And you can see here, right, it's the same education level, right? The weight for the married people is higher than weight for the unmarried, right? This would lead to here, we say the married person earns more than unmarried person by, yeah. So this way we explain the coefficient. Yeah, we explain the coefficient here. So any question here? Any question here?
Thầy ơi cho em hỏi xíu là cái này là kiểu nó kêu mình tính cái mối liên hệ giữa wage với lại dummy variable thì mình làm cái này đúng không ạ?
Mối liên hệ là sao? Thì ý như là nếu là cái biến đó là biến biến số, biến bình thường thì mình diễn giải giống như trên đây. Còn giả sử như biến đó là một cái
Dạ,
biến giả, biến dummy thì mình diễn giải giống
dạ.
cách như này.
Dạ rồi em hiểu.
Ừ. Yeah, and remember here. So for the dummy variable, right? For the dummy variable here, we, as I say, right, we need to define the base group and the main group, right? And we cannot include in the base group and main group, I mean, at the in one model at the same time, right? For example, here you would like to investigate, right, the impact of gender, right? The gender on the weight here, right? And you define female is a dummy variable, right? Is a dummy variable equal to 1 if a person is woman, right? And equal to 0 if a person is man. That's mean here the man equal to 1 here is the main group we have, right? And here we have is the base group, right? And you can see here in our model, right? In our model, we only have including the female, right? So we do not including the other dummy variable like the male, right? So because the male, the effect for male is the constant here. Yeah, and this is the additional effect for the female, right? For example, here you cannot include in one model, it's male, both male and female, right? And because we know that male plus female equal to one, right? A person either they are male or female, they cannot male and female at the same time, right? So this will lead to if you including the male and female in the same model, right? You have the perfect collinearity, and actually you cannot estimate the model, right? And here you can choose one of two model here, right? You choose the female is a base group, right? So and then you include the female, right? And if you choose male here is the base group, right? So you include the male here, right? So you cannot include the male and female at the same time, right? It is you fall into the dummy trap here, and you actually, yeah, you cannot estimate. Yeah. For example, in this model, right? We have the marriage and education, right? Marriage and education. And now you already define, right? The marriage equal to 1 for the married person and 0 for unmarried person, right? If you have another way to define the dummy variable, for example, the unmarried, if you define unmarried is equal to 1 for the unmarried people and 0 for the married people. That means here we have the unmarried here. For example, this is Marriage equal to 0. That means unmarried equal to 1, right? And similar here, marriage equal to 1. That means unmarried here equal to 0. Yeah. And similar here, you can say here, the if you sum marriage and unmarried here, it equal to 1. Yeah, this is linear relationship between two variables. And actually you cannot estimate. Yeah. And okay. And yeah, similar here, we have, right, holding on other variable constant here, right? So the coefficient of the female here, it is negative, right? That means the woman earns 1.81 less per hour than male, right? But later we will test whether this coefficient is significant or not, right? And although it's negative, but if it's not significant, that means actually the relationship is equal to 0. Yeah. So, but this is the way we explain the coefficient, right? The way we explain the coefficient. We will test whether the coefficient here is equal to 0, different. Uh, so we will compare the effect between the main group and the base group here. Yeah. And okay, similar here, we have the dummy variables, right? The dummy variable here is you to test for to evaluate, right? To evaluate the uh, policy change or the policy program. For example, here, the government, right? The government would like to test whether, right? The government would like to enhance the training activity in firms, right? In firms, and they give the money to firm, right? They give the fund for firm to for the training activity, right? And after the RAM, they would like to test whether this RAM is effective or not, right? And you can see here they define range here. Is it a dummy variable, right? Dummy variable equal to 1, right? Equal to 1 if the firm receive the money. Yeah, the firm receive the money, the firm receive resources or the funds from the government, right? Equal to 1 for firm. And 0 otherwise. 0 otherwise, that means firm do not receive anything. Yeah. So we have some firm they receive money. Some firm they do not receive anything, right? And now they would like the government would like to compare the effect between two firms, right? They estimate this model, right? And they including the rent here, right? The lobster here, right? Employee here, yeah, employee here, employee here, and you can see here, and the dependent variable it is ours training per employee, yeah, per employee, and you can see here we have the coefficient is positive. That means holding on all the variables, right? On all the variables, constant. Yeah, on variable constant because we have multiple relation model, right? On all the variable constant, right? Firm with range. That means the main group here. So this is the main group, right? Main group. So firm receive money, right? Firm receive money have a higher training per employee because we have positive, right? We have positive, yeah, positive here by 26.25 hours, right? 25.25 hours, yeah. And so this will lead to, so this RAM is effective, right? Because after they receive money, right, they increase the hour training per employee, yeah, per employee here, yeah. So this way we use the dummy variable, right, to evaluate the policy RAM. That means we compare the effect between the uh, in the empirical analysis, right? They define the main group. For example, here the rent receivers, here it is treatment group, right? And the firm do not receive anything. They define the control group. And then they will compare the outcome, right? They will compare the outcome. For example, the outcome here, this is the training per employee. Yeah, the training per employee. The outcome here between the treatment group, the treatment group here. This means the group is vetted by the policy, right? By the policy. For example, your firm receive the money. Yeah, but my firm do not receive anything. So the government would like to see the difference in the outcome. For example, the out training between your company and my company. Yeah. And your company, You receive money, you are treated roof, and I do not receive any money, so I control roof, right? Yeah, and so this way they use a dummy variable to evaluate the policy change. Yeah. So any question here? And so I think that's all for the.
Excuse me.
Hmm?
I have a question. Like, could you go back to the previous slide, please? Like, during the last lesson, I didn't see the log near on the equation, but now we have the log like that. So I want to ask, is there any difference between using the log and without that? And I know when we need to have the log in the equation.
Okay. Actually, there are several reasons why we need to use a log, right? So, so we use what log, right? In some model, right? Not not some model, right? In the model, right? Sometimes you say that they use the cell, they just use the level, right? If they use cell, right? This is the level. This is the level, right? And sometimes you can say that they don't use cell, but they take log of cell, right? Log of cell. This is the log level. Yeah, log level. Log level. So the reason to take log it is to reduce the outliers. To lead. Actually, there are several reasons, right? To reduce the outliers, right? Because, for example, suppose that you have the uh, you would like to investigate the impact of inflation. Suppose that inflation on GDP, yeah, GDP, and you use the data of, for example, 200 countries around the world, yeah, around the world, and you know that for the country around the world, you will have many developing country, and we have many developed country, right? And you can say that for developed country, right, the GDP is very large, right? And for developing country, sometimes some country the GDP is very small, right? That means we have a large difference between the large difference between the GDP, the large difference in the GDP between the developed country and developing country, right? So if we include in the model, right, include the model, they have the outliers. And but you know that in OS model, right, in the ordinary least square model, we would like to minimize the sum of square residual, right? But if the data, I mean the difference between the maximum value and minimum value become large, right? This would lead to it increase the residual. Yeah, increase the residual. And when they increase the residual, this will lead to it reduce the accuracy of estimation. Yeah, accuracy of estimation. And this will lead to we need to use log to reduce the outliers. Right? For example here, suppose that we have the GDP here of a country, right? A country, the first country have the GDP only 100, right? And the second country have the GDP maybe the let me see the number here. Okay, maybe it's a million, right? So you can see the big difference between two countries, right? And in this situation, if you use level, that's mean the GDP. So it increase the residual. Yeah, residual. Yeah. But how about if you take log of GDP? Log of GDP. Here, it is 2. And here, yeah. Okay. You can see here. When you take log of GDP, so the difference between the second country and this the first country only 4. Yeah, it's reduced, right? Reduce, and it can have up to reduce the outliers, right? The outlier in the data. And this is the first reason to reduce the arrears. And the second reason, the second reason here, it is easier for us to interact the result. Yeah, because here, when you use the level, right? When you use the level and you explain the coefficient, right? You explain the coefficient. That means you say 1 unit in rate, right? 1 unit in rate. For example, we have, for example, GDP. Uh, for example, we have the inflation. Suppose that we have the, here we have the GDP, right? Uh, FDI and GDP. So here we have the GDP. Yeah, suppose that we have the, we would like to investigate the effect of FDI on GDP. We have GDP equal to A plus B FDI, right? GDP and FDI, and but you can see the GDP of one country. Yeah, one country is very large.